Anti-static flooring for your manufacturing facility. Avoid common pitfalls when specifying. Most electronics manufacturing and test facilities use some sort of anti-static flooring in order to prevent component failure. This static control flooring is described by different names: anti-static, static dissipative, ESD, conductive, dissipative, grounded, static-free, and static resistant. Static control flooring must prevent static buildup and allow the safe dissipation of pre-existing static charges on people, equipment, carts, chassis and seating. If due diligence is performed, a static control floor fulfills the buyer's expectations. If the flooring is not properly evaluated as part of an entire ESD control system, with all environmental factors considered, then it is entirely possible that the floor can contribute to the same problems that it was designed to eliminate. A common pitfall that buyers fall into when choosing an ESD floor is the failure to recognize that floors are only one piece of a comprehensive, multifaceted static prevention system. Static dissipative flooring cannot be evaluated in isolation. To ensure proper function, ESD flooring must be tested in conjunction with other ESD control components, including conductive footwear. If the ESD floor and the conductive footwear are not compatible, the floor will not be in compliance with ESD Association standards, which limit body voltage generation to a maximum of 100 volts. Prior to selecting the anti-static flooring and the controlled footwear, different scenarios should be identified. Personnel cannot sense static charge accumulation until the discharge reaches 3500 volts or greater. Workers could easily generate 500 volts of static charge on the new floor and not realize it. Therefore, the footwear should be evaluated at the same time as a new ESD floor. It is critical to perform system tests that measure resistance and body voltage generation in the area under normal conditions. This is very important for any dissipative and resinous floor coatings. The range used to define dissipative materials is broad. Many epoxy manufacturers and distributors carry high-resistance, dissipative floors. However, these floors often generate human body voltages that exceed several hundred volts. To ensure on-site tested body voltage generation less than 100 volts, it is recommended that the resinous floor selected meets a resistance range of 1 to 35 million ohms. For best quality control, anti-static flooring and footwear must be tested simultaneously. If a facility uses only conventional pass-fail resistance testing, a problem could result in the ESD control system, with no possibility of detection.